we should be live now. Welcome everybody. Good evening. It's another Tuesday. Time to do some more Advent of Code. I hope everybody's had a nice time. It's good to be back. Let me tweak this out. Let me drop it in the Discord. And I can drop it here as well. And now I need to go back like this. Okay. That should be it. Okay, let's close this, minimize this, move that out of the way. Okay, I think we're good. Let me open it up here to see if it works. Yes, looks like everything is working. Okay. Okay, so let's see. We were doing Advent of Code 2016 day 11. And I didn't finish last time because there were some issues. Hey Smap, welcome, good evening. Did you have a nice Christmas? Let me see. I'm just going to my day 11 where I left off last week. One thing that I still needed to do was to incorporate the elevator, the state. Smap says, how did you get on with this? I still have not attempted it. I was okay. I did a priority queue, but that's probably not needed. The thing is, I had a state per thingy. And what I actually need to do is just incorporate the elevator floor as well in the state. But it didn't finish. Okay. That's a bug. That might not help. Okay. That might have been an issue. Do you have any of the stars left? No, not yet. But I just noticed the bug, so it could be like I validated everything worked, so my logic is fine for validating floors, etc. I just have to do the finding thing first. So let's run the test. I don't have the test answer in here yet. Let me see. 11. Okay. So it works for the test input. So maybe that was just the issue last time, that I had a bug. Like I just noticed there's this nesting here. It would first attempt it, validate it, and then it would add it to the new floor, but it did item 2 twice, so that's an issue. Snap says, I wrote the parsing and modeling part and then I left it. Okay. So I think I can run this on the real thing now. Let's see if that works. Okay. Looks like it's too slow. So I probably will have to do the thing that I had in my mind, incorporate the elevator floor as well in the state and then write it in just to a simple queue, not a priority queue thing. Because I don't need to keep track of every individual state, because basically it's a shortest path issue. But what I did with my state solver here, and I have two, let's see, I have solve P1 and solve PQ with priority queue. Hello Amarte, welcome. How was your Christmas? So this one, I don't incorporate the actual floor into the things that he tried, because I convert everything to a U-long, so I need to make sure that I can actually fit the state in there, or maybe I need to make it 2 parts. But yeah, For you, Amate, I don't know if you saw, I found a bug in my code. This one said item 2 twice, so it didn't work. But now it worked for the test code at least. And it seems like the current approach with the priority queue doesn't work because it blows up too much. It's probably doing way too much work. So if I convert this into just a BFS, a simple BFS, it should work and be faster. And if that doesn't work, I have to see if I can write some actual logic to solve it instead of brute forcing it that way. Amata says, Christmas was lazy and good, thanks. And yours? Mine was, the Christmas itself was nice. So Christmas Eve, we went to my mother. And we had a nice evening. It was like nearly midnight before we left. So we usually don't stay that late with the kids. But yeah, it was nice. We chatted and had fun there. First Christmas Day we spent with the in-laws, and my wife's sister came, and they have 2 smaller children, and they're a handful, but they're really cute. So I spent a few hours entertaining the kids, and then I was beat. So after that we played some card games and had a really nice day. And the second Christmas Day we just everybody was just wearing sweatpants and comfy clothes, and we just hung out a bit and yeah, had some fun. So yeah, it was a pretty chill Christmas. No stress, no arguments. It was nice. Smap says actual logic. Oh no. Yeah. So yeah, I think I will need to change my algo here. So let's take this version and write another one. So this will be just BFS. And now I wonder, let's try something here. So let's do public record state ulong floors byte elevator. Okay. Top level statements. It doesn't like me declaring that here. Okay. Sure. So I can do var a is new state 1 2 3 u at 1. Var b is new state 1 2 3 u 1. Console that right line a equals b. So busy times, at least in my view, us we each sat in front of their computers and just did whatever, games and coding, then just some cooking and that's it. Ah, nice, nice. Yeah, that sounds comfy. So okay, I just wanted to verify that if I create like a record for the state, if this would work. So that is nice. I knew it did, but it's best to verify if you don't do it that often. So I would create that here. So I can do record state ulong floors byte elevator. So this will be a state instead of the what is it? This one. So we can just make this a queue, and in this case I should mute this because it will, let me just see who it is. I think it will be Luke probably. No, it's something else. That's from the kids' musical school. Not important. Oh yeah, also I did this on the second day. Boom, 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 boom. I don't know if that shows properly. Let me see. I can probably move this here. Okay. Okay. I'm not sure what it showed, but I also played around a bit with Godot, just because I wanted to recreate a card game. So I set up some things here, but I'm still working on making it nice. So basically, let me clear all of this. it lets me create like a table, and then I wrote something that at least the play areas are there, but I still need to do some math to do the scaling properly and place the cards correctly. So that's also to be determined. Yeah. My Twitch monitor here is blank, so let me check if that's an issue of that stream or if there's actually an issue. No, it shows properly when I reload it. Cool. So yeah. Hey Luke, welcome, welcome. So we need to probably don't need all of this. What's the issue here? We have the elevator floor and let me think. What does it need to track? It will need the current state. Let me see what my old. Yeah, okay. I need to do this because this is the actual state thing, and I don't need this one. So I can just call this a queue like this. And then we keep track like a hash set of state visited, like this. Then we enqueue, what would be the first thing? Elevator floor, the start of the floor is there. We don't need this, we don't need this. So this will be the start, like this. And that would be, yeah, int move count, something like this, right? Okay, so here it is, we have this, this is all fine. If not, visited, and hash would actually be new state, like this, elevator, and this would be next floor, target floor, like this. This would be contained. Where's try count? Okay, that was just my global tracking thing. That's fine. We don't need this. Visited, add hash. True if the element is added, false. Okay. So we can just do like this then. If visited.add, this will be entry.move count plus 1, like this. And this doesn't need to be the copy. Yes, this does need to be the copy. We don't backtrack like this. Same here. Action try go to floor. What do we need to put into there? That will be a list of items. No, I can just do that in here. So this would be something like that. So like this. No, it's different here, right? I don't. Never mind, I'll just leave it as is. Because I checked them in one go and then I would have to do 2 checks. So it's fine, it's fine. I'll just update this version here as well. Boom, 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 boom. We have the permutation there, valid floor state. That the hash is actually new state here. Target floor. Visit add this. This we don't do. And this would be entry.move down +1, like this. Oh, it actually did something. Oh no, that was my other one. I stopped it running. I forgot about that. I thought my old code completed. We have that changed there. So now we can do solve BFS. Let's see if this works. Still not too fast. Am I still missing something? Oh, it worked. Just not too fast. Let's see if the answer is 47. Woo! Gold star. But this wasn't fast. it was okay, but not fast. Let's see what part 2 holds in store. You step into the clean room, separating the lobby from the isolated area and put on the hazmat suit. Upon entering the isolated containment area, however, you notice some extra parts on the first floor that weren't listed on the record outside. An Elerium generator and microchip and a dilithium generator. These work just like the other generators and microchips. You'll have to get them up to assembly as well. What is the... on the first floor? Okay, so I need to manually add them there. What is the minimum number of steps required to bring all of the objects, including these 4 new ones, to the 4th floor? Okay. Okay. Thanks for the stars. How much does this blow up the logic though? Let's see. So here we need to oh wow, I didn't even see the message. Thanks for the mod action there. I wonder who would target my stream to spam, like the reach of a whole like 5-6 people. Oh well. Let's see. So I do my prepare input. So now I can basically do, what was the floor item here? How did I make that? Let's see. This part here. How many elements do I even have? Let me just let me run this again. Oh, I also need to record the answer. This was 47. Important. Floors. One, two, three, four, five. Okay, so I have space in my bytes, right? Yeah, I have bits. I have bits to spare, so it can fit. Nice. I have bits to spare. I was thinking like that maybe I have to rewrite everything, but that's okay. So basically, we have two elements: const string delirium. Like this, we have two of those. Not that it matters, but boom. So we need to do this part here. Yeah, I can just make a function element ID lookup. Yeah, that doesn't matter. I could just do it like this. I can do void add element string name. Get or add element ID. So I can just do byte like this. Try to get value out, but it's an int. ID. ID. ID equals this. So I can do now int lyrium ID is this. Come on, like this. And now I can do floors, and this would be, did I do 1 or 0? I don't even know. Yeah, I do floors 1, dot add new item. Name is Elerium, is generator is false, and we do the same for true, and the same for the other one here. And I notice that I don't even need the IDs. I thought I needed them, but that's not needed. So I just need to have them in here to make sure. So I can do get or add for this one. Just to clean this up. Sorcerer, more AOC, yay, yay, welcome, welcome. Yeah, we're having some AOC fun. Have you done Advent of Code? And if so, which years have you done? Always curious to see what everybody else has done. So we did 2025. And now we're going back to some of the ones that I haven't completed yet. 2016 in this case. We're doing day 11 and we're doing part 2 right now. And this requires us to augment the input. Augment the input for part 2. So that should be it. And part 2 is just part 1 again, actually. So much stuff here. And I need to reset the floors, actually. So I need to make a copy. So I need to make sure, and that's something that I forget every time. So let's see if I do this. Let me write it in a way that I make sure that it's all cleared. So we need, it doesn't really matter, floor items, floors. What I can do is just here, so clean everything so we can start fresh. Or I can just create a clone and process it on that. Nah, it's okay. Well, doesn't matter. I'll just do it this way. Clear. This one doesn't matter because we reuse all those IDs. Total element count. We reset that as well. I don't think it matters because I don't use that anywhere, do I? Okay. Oh, I actually... Let me think. I need to remember to do that here as well. Just because we need to use this for tracking, so that's important. So we repaired that, we reset that. I think that's all. These are all local. This is local. Yeah, that should be fine. So I can just call prepare input again to have it all cleared. And then it should be able to do part 2. And part 2 is basically just part 1 again. So we can call it the same way as we did. Oh man, I wrote so much code for this. Boom, 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 boom. Elevator floor is this. And then P2 is this. Okay. Can reset that as well. Let's also drop this here. Okay. So we can run this now and see if it is able to do part 2. Let me remove this. But since part 1 wasn't very fast, I wonder how bad part 2 will be and if it can do it in time. Maybe I still, like here, it did 500,000 operations and it's not that fast. So this one will blow it up even more. Let's see if we can see something in the code that can make it faster. We have a queue. The thing is, I check all of this, and this might be too heavy because my reasoning was that it might be fast to check this, but we don't get to do the skip here because the things that we have to do to build that hash also take a lot of effort, because we have to manipulate everything and clone it, and so our logic here might screw us a little bit. So I'm thinking, I wonder if there's a way to make this lighter without all the memory copy and stuff. I could probably also not store it in the way that I did, like the items with the strings, etc., and just fall back onto IDs. Because we added 2 more elements, which like it will add so much more to the search space. Let me think. Because this thing right here is not the most efficient. So I can do item by ID, and then I can do, I think I can just do byte element ID like this, because how many items do we have in the queue? It won't break now because I modified the code. I want to say I see a lot of memory operations, but maybe if you store invalid state, so valid state is valid state finishes early, or do you have that? No. The thing is, to create the state already requires a lot of work, and I probably need to optimize that further. Oh, it doesn't like that. I hit pause. Yeah, okay, never mind. Okay. So it has 633,000 items in the queue. If I dequeue it, move count is 28. So you see how much it blew up the search space. We're only halfway there, but we already have more, traversed more. So yeah, making this more efficient will be important. Let me think. I was doing this, the item by I will kill it now because it won't run in time. This item by ID, let me run the prepare input here. If I set a breakpoint here the first time, I think the biggest value should still fit, like the element IDs. Element ID lookup. Yeah, and then you go to 32 and 65. Yes, okay. This should still be like a byte. So not sure why I made an int, but it's okay. So let's make this a byte. Byte. Just like I said there. That is fine. Byte. This result then needs to be cast to a byte. And that is fine. Is my code here still working? Yeah. I want to change this to be item by ID, like this. List of item by ID. Is valid floor state. You need to make a version that accepts item by ID. This will be like this. Element ID. Cool. So this works, that is nice. Boom, 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 boom. So build hash will also need to have a overload function that accepts the ID like this. And build floor config needs to have a version by ID like this. Item ID, element ID. Like this. Okay. How many errors do we have that we still need to fix? And then the generate map will also need the same thing. Byte. Oh yeah, now I don't need to do this lookup at all. I can just do entry.key. So this becomes more efficient. That helps. Okay, let's make a version of this. As well. Oh, did I change that one? Okay, fine. Boom, 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 boom. And then we have same thing here. Okay, so element ID. Luckily, we already got those IDs. This function needs to return a byte. And we already know that it can. Like this, okay. And now we need to fix the prepare input one to also do the other thing. So we do byte element ID equals this. List item by ID floor item IDs like this. Okay. This generator element ID is element ID. Okay. That was a whole lot of work. Let's see if that makes part 1 faster. It's just a little bit less overhead, so it might make it a little bit faster, but that still doesn't solve our main issue probably. Okay, let's run this. What's happening here? Entry.floors for probably missed something. Boom. Ah ja, smaakt. Floors by ID, floor items. Okay, forgot that one. And part 1 is still too slow. Great. Remember, I changed part 1 as well. Oh! How is this possible? Ah, because I don't clear them. It just finished part 1 and now it runs again. So, okay. Boom, 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 boom. Because I didn't clear this one. Okay. So now a whole messy code here. This one still isn't fast enough. Basically, we want to try this earlier, but to do this, we need to do all of this. So let's see if we do it a different way. So we do this. And then this, and then we need to check hash like this. Now we still need to validate it. So we might blow up this with unneeded stuff, but it doesn't matter. That gives us the option. So now we need to make sure if is valid floor state. This one. And the next one. So let's see if this is faster. Doesn't look like it. It did less work, which is weird-ish. How can it have done less work? Oh, I also only changed one of the 2 loops. I just remembered. I should have timed this, by the way. Like the before and after. Let's do that now. Do we actually? Yes, we do need to. do that. Let me think. So I can do this. And I need to do the same thing here. Like that. It needs to be this one. Then we don't do this and do it like this. Okay. Let me put back the old one here. And then we should probably just measure which one is faster. And we do that with part 1. Part 1. So, let's see. Stopwatch dot get timestamp. Start is this. Actually, I can call it P1 start, P1 end. And we can do process input. Oh, how did I call it? Input. Prepare input. Okay. Then we do the same thing again. Console, the right line. Old. Stopwatch, get elapsed time. So this will be P1S, P1E. Okay, let's see which one of the two is faster. And then I need to think about how I do things even better. But okay, so the second one was faster and did less work, which is sketchy. No. Let's try the other way around and see if that matters. It seemed to be like a 30% speed up, 30-40% speed up, so that's nice. Let's see if we run it the other way around, if it's just as fast, because like the whole warm-up time also makes a difference. The fact that it tries different things is weird to me. Okay, so with the warm-up the other way around, it's less fast, but at least it does the same in less work. So that's just, when the logic should be the same, this is really weird to me. So there might be still a mistake even in my normal BFS logic here. Oh yeah, I only checked one floor here. So so it should also check this one. So that would make it even slower. But that might be the reason why the other one checked way more than it needed to, because it tested a lot of invalid ways. So, okay. So that's at least something. So with that out of the way, could we run part 2? Let's see. And the alternative way was faster. So we can remove that one and make sure that we do the alternative way. Oh, I never even triggered it, the alternative way here. So let's see how long this takes. Okay, what's the issue? Ah, okay, the old versus new, yeah, got it. So I wonder if that makes part 2 feasible. Because it does so much less work now. Still probably need to find a more efficient way to do the existence check if we done that, but something tells me that this should complete with like not too much time, maybe. Let's see how big our queue is right now. Only 83,000. Why is it so slow? How come this is a lot slower? Or has it just, wait, how much moves has it done? 22 only. So, it's weird. So it's the actual checking, like the valid floor state stuff probably, that still isn't that great. Amata says, maybe printer try it anyways every 10k or something to see some progress. Yeah, but you probably also want the depth of moves. Since we know that it's 47 for the old stuff. Because like if this is still at 22 now, so it's 25, but it will keep growing fairly slowly, which is a problem. I wonder if I reduce this to, because this hash state, like I could do away with a lot of this stuff and just make it more bitwise operations. It's just so much code to refactor. That's a bit of an issue there. See, we're only at 27, so it will take this will take a long time to run. See, this has already tried 6.8 million ways. Let me see. Trying to think of, you said something about the failure conditions, that you also try those. I'm just wondering how I would more easily check that. Because like in my mind, the valid floor state, etc., it's not that heavy, but heavy enough, obviously. Just trying to think like, where can I shortcut something to make it more efficient? I wonder if that, like, if I would do the aggressive inlining thing here. So I guess to dictionary and dictionary operations are heavy as well with this amount of work. Yeah. The thing is, I can pack the data pretty efficiently in just 4 U-longs. I would just have to write smarter functions that interpret this to see what the bitwise operation would be. Man, I just wish this was faster. 32. And how much have we tried? 11 million. Don't we wish it all? Yeah. Let me think. Because like this, so like I could do U-long add element, add, so this would be U-long value, and then you would have byte element, byte floor, byte element ID bool is generator. Could do something like that, so then you would have so yeah, every floor would be shifted over. So int floor target is floor times 8, 16 actually. So it would be floor minus 1 minus 1 times 16. Right? 1632, so 0, 16, 32, 48. That would be the offset for the floor. Then you had the element and then the generator. What did I do for generator? Was the element? Generators were shifted over, microchips, okay. So, boom, 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 boom. So we have this for the floor, is generator 8 like this. So then we would do a return value no, it would be element ID, right? Like this. Martin says you could try to use method timer.fody to measure what takes so much time, or some other benchmarking method. Maybe data representation is not the problem. I also think it is, but I also think it's better to check before committing to refactor and bug fixing. Sure. That's annoying that it doesn't want to pause there. Just because I'm editing the file. So we'll generate a source representation. Oh, this is so slow. So we are at 35. Yeah, this will run for so much longer, so I will just kill it because this won't run. There is a benchmark tool actually. Never used it in my life. Performance profiler. Sure. Start. Oh. Hey Black Eye, hello. Welcome. We're doing some measurements to see what is taking so long with the code. Memory-wise, it's not that bad. Then whoop! Okay, I think we can kill it here. Let's see what it says. CPU hashset.add. Okay. So to check if we, that's actually not too bad. Add if not present, yes. So would that be the issue? Probably not, right? Because if we want to add it anyways, build hash also takes up quite a bit of time, but basically checking if the thing exists causes some headache there. Might that be because it's using a U-long and a byte? So maybe that as a key is not optimal. Let me think. I wonder if I would reduce it just for funsies. If I change this instead of state to just be U-long, just to see how it performs, right? It won't work now because it will try stuff that it shouldn't. Actually, what if I do a dictionary of this and then a hash set of bytes? What if I do it this way? Let's see. If visited try get value hash. Well, as it might be, I think it does dereferencing of the tuple type. I know that even AB memory on the heaps is ref type and not value type. I learned that while trying to do my no memory use waving. Okay. So let's see if this has an impact here. Try get value hash out var floors. Visited. Target floor. Actually, is this the right way? Do I need to do the target floor or the current floor is something that I wonder. No, I think the target floor. That is the way that we go. Yeah, I think this is fine. Then we do do a try. This is annoying. Not hash exists or that. Okay. If not hash exists, visit we do elevator positions is new. So we can do elevator visited.add hash elevator positions like this. And this would be target floor. Like this. And then we can do this whole thing. Boom. Ba-dum-bum-bum. I should probably measure, but this should also run faster than it had before, and I don't think it's making that much of a difference right now, because this should complete faster than it does right now. I think it's actually slower. Okay, Jesus. Ah, there's a bug here. Never mind. That's a bug. That's a sneaky one there. Didn't feel much faster. $17. Let's benchmark this again. Where did I see that? Performance. Let's see. That should give us a fair sample. Yeah, it's still most of the work just checking if we... Why is this so inefficient? I mean now it's a U-long and just checking if we've done that. So are we doing something else stupid? The build floor config is also fairly heavy, but like I'm surprised that it's like so much of the time is just checking if we've done this or not. So, actually we don't need this. Don't save. Int fast keyboard length is 0. If entry.move count larger that's release build. I don't think it will make much of a difference, but debug start without. Okay, it's still building. Let me see. Do I have File Explorer? Let me see if I have my session file in the release folder. Release.NET 9. It's in there. Cool. Okay. Oh. The empty green triangle thing next to the debugger start with it. Okay. Good. Yeah. This will grind to a halt. I'm gonna go for a quick pee break. Do you watch the screen for me? I'll be back in a jiffy. Let me mute. Okay, I'm back. How long is it taking right now? It's like 21 seconds per level right now, and that number will only go up. So we don't even reach the 47 that we needed for part 1. And we added 4 items that need to be moved, 2 elements. So I'm thinking or wondering if there's if we look at actually how the solver solved it, if there's a way to just repeat that regardless of how many items you need to move. Like if there's a strategy that you could just code up. Because basically they go to a state where they just bring everything up. So I wonder if we look at the 47 steps that it does, so it goes from 11 to 47, if there's a pattern there that we can learn from, right? And just actually implement the logic. for how to do this. Which is probably the fastest way to do this, because it seems like this isn't really working. Another thing is that that we probably want, like I could do a ranking where you assign targets to each level. So the higher, if something hits this level, it's 4 points, 3 points, 2 points, 1 point. And then just keep processing the one that has the most points, so that you can that way incentivize doing the ones that is doing the best. But then again, you don't guarantee the shortest way to do it that way. So you need to have like a BFS kind of thing to ensure the shortest path. You can see like it like the further down you go, you just add so much more state and options, so it will only get longer and longer for every item that you try that you add. I could make, actually I could make this lookup go the other way around and see if that's faster, so that we just first check it by floor. Because like I said, waiting for this to complete is not an option probably. Like this is now a minute per level, and this will only grow and grow and grow. Let me think. I wonder if it would make much of a difference if we just split this into doing it the other way around. So we have a dictionary. First we separate by floor and then by hash. Martin says, I wonder how much multi-core approach would help with that. I know it's still brute force slower, but still. Nineberry says, hi, part 1 done. Yes, part 1 is done. And I've changed some things and optimized some things, but it's too slow for part 2. And I am running out of ideas of what I could do, because we profiled the code, and the biggest issue is just this part here, like checking if we've tried it or not. So this is a branch that we run into a lot, which is annoying. There's other stuff that can be faster, but just this basic check is also just very slow here. Nineberry says, yeah, you need an algorithmic improvement idea. That's the one I missed and came to me under the shower. Okay. Yeah, the thing that I talked about earlier was looking at like the difference between solving the test and then part 1, because it jumped from 1 to 47 moves with the added elements. And I wonder if there's like just a basic strategy that it implements that you can just execute per element. Like that's the only thing that I was wondering, like, okay, if there's a targeted way to bring something up the most efficient way, regardless of how many elements there are, like it's just you need to do this and then that, then we could probably have like a recursive function that just does the moves in the correct order. But yeah, this is like, it will keep, it still runs and it will keep running, but I wonder how much steps it will be. Probably a lot, given how the search space grew. But yeah, this will not complete in time, so I'll kill it. Which is sad. And I wonder... I've written so much code for this, and alternate versions, and so I think I can actually, if I do this and then just exit, so I can just do solve P1, start, and pim, and this would be... Luke says, if you keep talking, the program might just finish. I just killed it. I don't even know how I did the first one. Here. Let's see if we just after P1 just exit here. Part 1, and then we do return. Boom. Because this one should show us the moves, I think. Overflow exception, okay. Nice. Okay. So let me alter another one here. No. Let's see, we want to do solve P1, PQ, I think. Elevator floor, floors. Like this. Let's modify this one to also do the print hashes here. Come on. I mean, this should take like, I think 10 seconds at best. So why is it so slow? Or was this the one that didn't work properly? No, this should work. Man, it's slow. This is a release build as well, so I can't pause it to see how far it is. Oh, did I do any output printing? Yeah. We did try this one, right? Or did we just rewrite it and then see how long that took? In my mind, it wasn't this bad. I was like, let's just run the program and then print out the route that we had, but it looks like this one is also just too slow. Marta says, I think it didn't work. You spotted the bug and then the queue just blew up. Yeah, but I fixed that one. That was that item, the second one here, item 2. And also this one didn't check. No, that one is also fixed. Okay, well I can, I'm looking at the wrong one here. This one. Yeah, this one is wrong because it doesn't check this one, the target floor one. It checks target floor, but it doesn't check the current one. So it should do this and then do this. And that cuts down a bunch of the work, but pretty sure that it's. And I reworked this one to do the hash part first because that was faster. So what we did was just do all of the work here and also just re-add it as well, then build the hash, then do this part, and then we had a check for both of these like this. That was the change basically. And this was a little bit faster, but not hugely faster. But yeah, we can do the same here. So now we would just do this. I also need to change that in the other one as well. Like this. This is nonsense. This one also needs to be like this because we already modified it. So we can remove one piece of nesting there. So that also removes a bunch of the memory operations. Now I wonder, did I do this properly here? This one we don't use. We use the alt. That one was better. Did I do this properly? Yeah, I do it properly here. Okay. Then try one more time to see if with the small changes, if it's better. I should probably also do this thing here, like the report length here. Let's see, where did I have my solve P1? Yeah, this one. Boom, report length, and then like this. And this one is just that try that count Let's see if this is feasible. It's so slow. This needs to go to 47. This is like slower than part 2. So I should probably modify actually well, didn't I change this one? Let me see. No. So yeah, this one is just way too slow like this. Great. So I wonder if it's worth it here to add more to the state. To have the actual moves here. Ha 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 ha. Let's see how that worked again. This way. So that's a way to do it, probably. No, that wouldn't work. I was thinking like you could do the same thing and then just like through the stack build it back up when everything reports true. I want to try this and see if this matters. And basically I will just preload this, so visited, add one like this. So now you can do if visited target floor contains hash I could do it this way, right? So this probably is a bit faster, but not fast enough. Same thing here. Let's clean up a bit of this code. But that still doesn't solve my problem there. How long did it take? 7 to 10, 3 seconds? Okay. It feels a bit fast. I'm curious to see. It won't be enough of a change to create a real impact, but now I'm just curious to see how fast the second part catches up. It's a bit better, but still too slow. So separating the lookup by floor helps quite a bit to make at least some of the lookups faster. But it bogs down here. Like this is already too slow. So I wonder if I expand the state here to keep track of the moves that we did. How did I even do that? The print hashes, is that just a diff? It just keeps track of the things. Okay. So I could, so I can do list ulong states like this. So this will blow up the memory usage quite a bit, but at least it will give us the track. So now we can do just a print out of each state here. So I can do print hashes and 3.states like this. So let's do this. Numbers get a lot slower each step. There is so many different possible states after that many steps, or so it seems. Yes. Let's see. So this is the 47 moves, so it's not that bad. I should probably do this in reverse actually, so that it shows it the other way around. So it moved these two one, and then it went here. And then it takes one back, like it takes the two microchips up. Then it takes a microchip back, down here. And then it leaves behind the one that it took, and then it takes it to generators. Okay. Then it takes a generator back. Then it takes those two up. Generator back. Then it goes down with the generator. Then it moves a pair up. Goes back down. Brings another pair up. Okay. So the basic logic that it does, if I understand it correctly, let's see. So it like, for all the intermediate steps, it never has more than two complete bundles in there. So like if you look from this state, I should probably write something to turn this into a change set between each one of them, and then have like a cross pairing, like just A, B, because I think this is like a repeated set of steps that it does. Like it takes stuff from here, from this level, up, and then it goes back down and brings two, make sure that there are two pairs here again. But the wait, when is the first time that it brings two? Because it uses that polonium constantly. Right? Let me see. It brings one microchip up. And then it just transfers two here. Polonium, polonium. Yeah, then it goes down here, and then it leaves this one in here and takes two new pairs up. Then it takes the generator down and brings two other microchips up. Then it moves two microchips up further, goes back down again with one, and then goes back to the lowest floor. Then it pulls up two generators. Yeah, I think if I abstract this to just a change set and then have like the pair numbers, I might be able to figure it out. So let's work on that. Let's see. We have this one. Oh man, I drank so much tea, I need to pee again. Let's see. Print. I have this one here. Print hashes. Okay. Cool diff. Okay, this I can remove. Um, let's see, for int I is 0, I smaller steps, I, actually we start at 1. This, basically we do, let's see, C# interactive. What was the format again? B4, right? I need actually the div. That's not what I meant. Nope. And if you do the AND, you only get the matching ones, but I want the inverse of, like, yeah. That's only that one, but I want the ones that differ. Let me just Google different. That's not what I mean. That's the inverse. Yeah, the AND only takes the ones that are still the same. But what I want is, out of all the flags that are set, the ones that are let me think. Yeah, the XOR. That would be the one where they differ. Yeah, am I crazy? actually this is actually what I wanted. It must be, it's probably because it's late. This is exactly what I wanted, because only this one is different. It's the same, but I want the inverse of that. No. Hey Vika, welcome, welcome. Let's go back to the bitwise thing. Because I think I need... Is it the... or this one will give me both. Last one is Andy, you want... Sorry, yeah. I'm okay. I'm not doing great because I'm getting my ass kicked by day 11, part 2. It's too slow and I want to figure it out. Now what I want to do is between two numbers see which bits changed, and for the life of me I can't figure it out right now. Scooby Jesus says, which bit pattern do you want? What does string R to the string call to? That's a format. So in this case, I say I want to represent this value as 4-digit binary. So if you do this and you pass it B8, it will give you 8 bits. Like that. Scooby Jesus says, what bit pattern do you want? What I want is between these two, see which bits changed. Oh yeah, there's actually this one, right? Yeah. The thing is, I need to then check if they moved or added, because I think what I need to show is because I think I need this one and then the one that matches I think it's this that I need. So that would give you like, okay, it was here, but it moved here. So this would be the new state, and this would be where it came from if I do the reverse here. So if I take the difference and I match against the old one, so this way I can tell, okay, it went from here and it moved here. Yeah, I think that's indeed the thing that I need. So I can do var changes is this. Var removed is changes and this. Var added is changes and steps of this. So this should tell me which ones, what was removed and what was added. And now I need to turn this into my whole thing. Boom, 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 boom. So let me see. Void print ulong value step in this case. Okay, step. So what I can do now is say, okay, console.writeLine removed. Print removed. Added. And then do another console write line here. So to separate it. And then I can do away with this. So now if I go to the code and do a print diff, it should be able to tell me which ones have changed. So let me just put this here now. So instead of print hashes, we do print diff. So this should now tell me the changes for every step. So let's see. So remove these and move them here. Then we take this one and move it here. We take this one, move it up one. So yeah, this is okay. So the flow, you don't see the actual state here, but this is the steps that it does. So now it takes these two, moves it up, moves it up, moves it up, then moves this one down. Basically, I can do the removed and added. I can just skip that. Oh, out of range. I needed to do -1 actually. That was stupid. Print diff, this would be -1, like this. So we can skip the whole removed and just do the added part. Alright, boom. There's also a long. How many bits is that? No, that's a different language. Like the words short, int, long, they can mean different things in different architectures and languages. It's based on how many bits the operating system or language is in that case. So like a long in C# is 64 bits, but in some other languages it can be 32 bits. So there you have a long to be 64 bits, but you don't have longs in C#. What's the issue here? Index out of range, non-negative. I equals 46. Length is 47. What's the issue? Oh, it's the line after. Yep, my bad. The breakpoint, it breaks on the wrong place. Martin says long is 64 bits in C++. Long and int is the same, 32 bits. Ah, okay. But I've had there are languages where int is 16, etc. Yeah. So that's why if you're unfamiliar, you can always use like the bit shorthand. So in C# you can use int32. Like yeah, for every thing you have also the explicit versions, int32, int64, 64, uint64. So you can specify it like this as well instead of int long, etc. Vika says basically architecture, independent data type names, interesting design choice. Yeah, it's actually, if you want to be precise, it's better to use the specific length versions, but yeah. Since for everything that I target, it's pretty much It's just a convenient name that you used to. But if you do a lot of C++ programming, in C++, I always target like the specific bit versions. So I do I64 and U64, etc. But that's usually when I do smart contract things. Actually, that's usually when I do C++. It's smart contract stuff. So yeah, it moves two there, takes one back, one down, moves two up. So then it goes here, and then it takes a new pair up. It takes that one down, brings two others up. Two. Two microchips up, takes one chip back. Fika says, wouldn't it have been smarter to just call them int 16, int 32, and yeah, you have that. They exist all the way up to int 128. Yes, they exist actually. Now, since C# was meant to become Microsoft Java replacement, it was designed to be as platform independent as possible. That's something, at least in my mind, they did more stuff later on. That might have been an idea of wouldn't it be cool, but they still had to change quite a bit as the language grew and evolved to actually make it run very well on all other operating systems. But by now it really does, yeah. .NET has big int, which can be huge. Yep. Big ints exist in most languages though, even in JavaScript, etc. Marta says it would, that's why there are, yeah, int32t, int16t, etc. Unsigned versions, yes. Yeah, that's a good one. That's actually the types that I use in smart contract stuff. And yeah. It's a type otherwise, yeah. I mean, looking at this, it makes sense. Just like I don't see, there's a pattern, but I'm not great at spotting the pattern. Let's see. Let's do this. So I can do print added, skip and up, skip true. Let's do print steps. I can do it like this. AI says the _t suffix is specifically reserved for types defined in the C standard library. It's used to avoid naming conflicts with the user types. Okay. Good thing we don't do Hungarian notation anymore. With those types, it could become... Fix says, I think if somebody calls their own type int32, they deserve naming conflict. Yeah, and then you get into... Like in C++, you can basically rename everything. So that's fun times ahead, you know. There's an extra print line here already, so I don't need to do this one. I feel like I can stare at this for a while, but my brain is not clicking yet, and it feels like, okay, that like I see the general pattern. At least to me, it seems like, okay, you make sure that there's never more than 2 pairs on each floor, and there's a way to carry one up. So like, okay, let's see if I can deduce this. But I wonder why it would start here. They could also just, like, their logic later on would be to just, let's see, where is that state? They have a state when there's 4 on the second level. Here. They bring stuff up to that there's 2 here and then 2 here. So why not make this the first step, to just take 2 and make this go 4? Because this is the initial state. Elevator floor starts here. No, wait. How can this be the first thing if the elevator has to start on floor 1? I'm putting it out to floor 3. Let's see. Martin says, not everything. You can't rename keywords and digits, but in Dreambit you can. I'm pretty sure you can rename lots of stuff and have, like, replaced it with macros and do all sorts of weird stuff. But I remember reading about some very evil things you could do to colleagues. Yeah. And I thought there was very little restriction to what you can and can't do. I think you can do pretty extensive stuff, like, yeah. Because, let's see, the own language. Did my first and second job projects in Visual Studio 6, which had no language services and almost no IntelliSense. Yeah, I still use VB6 from time to time. So does Luke. Yeah, define true, false, etc. Yeah, exactly, stuff like that. Yep. We still have a customer using VB6. We're trying to get him off that, though. But it's been a long journey. I think for now I'm going to let this rest because I need to think this over some more. And I don't think it's getting much more. I think the chat is more interesting than what I'm doing on screen here. So I'm gonna quickly take a look at day 12. And see if that's a bit of fun. Because I'm getting tired and I want to do a bit more of coding before I stop the stream. Let's see, var 5 is... okay. Nightmare says the company we have some project in the company we have some projects that are still developed with Visual C++ 2010. Upgrading the compiler would require spending lots of money for clinical studies to confirm the result is unchanged. Oh wow. It sucks when you get tied into situations like that. So yeah, I hope you don't mind, but I'm gonna quickly read day 12 and see if there's something that I can do right now. Leonardo's monorail. You finally reach the top floor of this building, a garden with slanted glass ceiling. Looks like there are no more stars to be had. While sitting nearby... Oh wait, is this the... This is 2016, okay. While sitting on a nearby bench amidst some tiger lilies, you manage to decrypt some of the files you extracted from the servers downstairs. According to these documents, Easter Bunny HQ isn't just this building. It's a collection of buildings in the nearby area. They're all connected by a local monorail, and there's another building not far from here. Unfortunately, being night, the monorail is currently not operating. You remotely connect to the monorail control system and discover that the boot sequence expects a password. The password checking logic, your puzzle input, is easy to extract, but the code it uses is strange. It's assembly code designed for the new computer you just assembled. You have to execute the code and get the password. Is this was this the encode thing as well? Ah, okay. You have to create, execute the code and get the password. The assembly code that you extracted operates on 4 registers. A, B, C, and D that start at 0. You can hold any integer. However, it seems to make use of only a few instructions. Yeah, that was this one, right? Okay. Int computer comes only 3 years later. Yeah. Yeah, I was a bit confused. I was like, okay, was this the encode? But no, that's 2019. So let's see. Copy XY copies X, either an integer or the values of a register into register Y. Increment X. This is also a bit of the encode stuff. Decrement X, jump not 0. Jumps to an instruction Y away, positive means forward, negative means backward, but only if X is not 0. Yeah, sure. The jump not 0 instruction moves relative to itself. An offset of -1 would continue at the previous instruction, while an offset of 2 would skip over the next instruction. Okay. Offset of 2. Okay. Relative to itself. For example, the above code would set register 8 to 41, leaving a register because A is not 0. They move past the last instruction, the program halts. Luke says, I go to bed, see you guys later. Good evening, Luke. Thanks for stopping by. After executing the assembly code in your puzzle input, what value is left at register A? Okay. We can do this one. It's fine. Day 12. Let's actually go back to debug build here. Day 12. That's the assembly instructions. 12, 12, 12. Okay. Input, input, 2 lines, for each. Sure, for each string not line in loop. Let's see. What do we do for this? Internal static class instructions. Const string cpy name of cpy. Ink back J and Z. Instruction like this. That's the one. Sure. Public. This actually let's just do it like this. This is private. Let's see. Public void clear reset. Instruction index equals 0. Register up here. Okay. So, yeah. Let's see. Public. Let's do public record instruction. Now I wonder if I should have made this an enum, but it's fine. We do string instruction name car register int value, something like this. Something like that. Does that work? I think it should, even though the highlighter doesn't like it. Let's see. String parts is raw.split by ASCII whitespace, which is fine. if parts 0 equals instruction.copy return new this, and this would be parts 0, register will be parts 2, and then an optional value would be int.parse parts 1, like this. Return like this. Okay, and now it becomes actually I could do like return parts switch. So it could be instruction dot cpy What is I don't remember the switch logic. Was it something like this? Dot GNZ. So this one would be this one swapped. Something like this. Parts 1. No, I think it's something like this, right? Remove and you will be good. Const, it's const. Okay, yeah. I think this should be fine. Okay. Right, because GNZ has it sequential, copy has a reverse, and the other ones don't have anything there. So now we can have a public list of instruction program, which is fine. And I think I have the name in, okay, that's it. That's why it's being weird. Yeah. This sucks. I'll just make this the plural one. It's fine. So I'll just do this. Okay. Instruction T. Yeah. That would be on brand. Nice. Let's see. It still has a bunch of errors. Let's see. Yeah, this one. Return instruction index. So yeah, let's see. Put like this. Okay, that cleans that up. Let's see. If instruction index larger or equal program.count, return -1. let's see. Const int exit code finished running public. Something like this. And now we can also do this. Switch. Yeah, I can do instruction hi is program instruction index like this, yes, and then we do switch i.name. Case instructions dot deck. Actually, I can just do dictionary string action instruction logic. This is annoying because you can't initialize it like this. So you need to do it like this, and then you can do this. So now you can do instructions dot deck, and then do I like this. So the instruction for the decrement would be registers, no. Why doesn't it like this? I dot register minus equals I dot value. Registers is not null here. Sure. This would be static. That's annoying. I mean, could add this here. I mean, it's better to just supply everything that it needs here, but yeah. So then it would be reg like this. Can't implement further. This one will always be set. So that is fine. And it would also, okay, I think it's better if I do it differently, because you want to modify the register plus all the program counters there. So I can just do a constructor here. So public computer like this. So we can do this and then initialize it here and then just refer to everything that we need there like this. So now we can do register like this. And then we do increment instruction index. Yes. So that's the decrement logic. So now we can add another one here. Increment this CPY. Like this, and then we have jump not 0. Right, and that's the only one. So if not equal to 0. Wow, why all the way over there, bro? Else, boom. Instruction index plus equals either value. Yeah. So like this. We should probably assert that this is not 0. Debug.assert. Technically, we should also do more checks here, like if the register exists, but it should be like this. So you can also have a public void run, and you can do while, while exec not equals exit code finish running, basically. I did need to do that. So now I can remove this. So that should have been a clue that I forgot that. Computer is set up. So now we need to, yes, instruction of parse line list instruction in program is boom. Program.add like this. New computer, and then we do program is program. Okay, so far computer this. Should probably make this actually just global so that we have it available where we need it. So we can do a computer like this. Remove the var. We can do computer run. Let's do computer.reset here so that I don't forget. And what did we need to know? Register A, okay. So then we do P1 is computer.register A. And I didn't make that public. So I can make a function called public int get register car register. Try get value register alpha e minus 1. Let's do int.min value Let's just define it as a const as well. Invalid register is printed mint value. So now we can do here, get register A. P value assert P1 not equal computer didn't have register. So, like this. Const char register to read is A. Okay, let's set the date 12. Let's see if we can run our program. It's a lot of programming without running, but yeah, let's see. Seems like we're in an infinite loop, so that's a great a great start. Let's see. Oh yeah, I didn't exec actually. So I need to do logic I dot name I. So close. Boom. Nullable object must have value. So register A. So so that's an issue. Let's see. Did I do no? Okay, let's start at the beginning. Let's see. A is that, okay. Oh. Wait, no, that's not possible. Registers A. This is also A. Wait. That's interesting. How is it possible? Wait. Did I pause this? Ah, okay. Increment. I'm an idiot. I didn't implement the increment and decrement correctly. That's just it just adds one, right? Decreases the value by one. Yeah. I wonder if this works. Okay, that worked. 42. Let's run the real thing. False. Input string A was not in the correct format. Ah, that can also be another. Did I read that wrong? Ah, value integer or the value of a register. Okay, I need to. That's a good one. So the instruction, see, that's how well I read this. So this one needs to be try parse out int val and then we have another one. That's annoying. So now we do the inverse of this again. Oh man, that reads. Oh, come on. Why is it jumping? Okay. Can the jump not zero also refer to? Okay, that's fine. Boom, 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 boom. So this would then no, like this. Okay. So the copy I dot value has value, get register I dot register B dot value, like this. Given key C was not okay. Copies X, either integer or the value of the register, integer register Y. Yeah. Okay, let's see if the instruction, if there's something weird here. Okay, so they refer to a register that doesn't exist yet. So if it's not exists, we just need to treat it as 0. So that is fine. If try registers try get value out int r and r not equal to 0. Fine. Martin says you always have 4 registers, and I guess they start at 0 if not initial. Yeah. That's basically the logic that I'm doing right now as well. Okay, so now P1 is a big number. Answer is too high. Okay, cool. Interesting. Why don't you just initialize a dictionary with A is B, C is A? Sure, but now I can support any number of registers there. Try sample again after changes. Yeah, let me try that. It shouldn't matter, but maybe I broke something. Nope, sample still works. So let's see. So let's make sure this this one is correct. Let's run the real thing. Because the test doesn't have some of the cases that you have in the real thing. So the instruction here is A, set it to 1. B to 1, D to 26, I mean, still the same thing. C to 7. C needs to be set to A, so C needs to be set to A. That's 1. Sure, so this is not updated, that's fine. Seems fine. B needs to be set to C. Okay. C needs to be set to A. I mean, this all looks fine. Is there a jump not 0? No, it can be. Could it be? No, wait, it's too high. There's a JNZ15. What? Oh, that's weird. Let's see. If this is, okay, this can be a literal as well. Okay. So, sure, why not? So this becomes this is so annoying. Let's see. It's the same logic as this part. That's basically the while true. Yeah, I know, but I still want to properly support it here. So you want to do if it's this part, You want to do the inverse here. Let me think. So this one won't, it can be an okay, this first register can also be null. It will be if it's parsable by int, this will be null, and otherwise it would be like this. Right, let's see. I need to make this nullable actually. So this one needs to be nullable here as well. And then I need to do the inverse for the other one. So that becomes the second value. Should have probably just had so this would be int value to value b. It doesn't get cleaner like this. Because this one gets an extra null, and then this one gets the inverse of this one. Which is basically just this one. Like that. And the first one I can discard it. Nice and messy. So this one, in this case, so now this one becomes one case. Or the other case, I dot value b that has value, and I dot value b that value not equal to 0. Yay! By now I think I should have just stored it as a char and then do the detection there. Yeah. That looks better, probably. Woohoo! Man. The first half of the puzzle is complete. It provides 1 gold star. As you head down the fire escape to the monorail, you notice you didn't start. Register C needs to be initialized at the position of the ignition key. If you instead iterate register C, initialize register C to be 1, what value is now left? Okay, and now it will be like it will run forever. Well, I'm not sure. Computer that set register. Blah, blah, blah. Like this, and then we can just do this again. Except we do P2 here. Well, it might be that it's something completely different and that it will run like a very long time and you need to add DP or something. But okay, I needed to add this to the answer P1. There is no test for answer. Sure. Okay. Underflow. Boom, boom, boom. Do I need to make it larger? Well, I should have just made this far anyways. It's still a negative number. Okay. Okay. Let's see, is everything still correct? We have the logic there, program, registers, instruction index 0. Okay, it's weird. Why do I have Copilot there? Try not to set register C and check if you get the same answer as in P1 after reset. You'll know it works. That is true. I can do that. But the reset is super simple, so it should. Oh, I guess not. What did I mess up? Registers clear, instruction index is this. What? Whoa. That's really weird. Oh, I never run it. I'm an idiot. I'm an idiot. It's actually my no, it's not. I'm just really an idiot. Remember, the value that you get back is an int min value. We don't run the computer, so we try to get a register that doesn't exist. That is actually the issue. I never run the computer. So smart, so smart, so smart. Okay. Okay, there's part 2. Jesus Christ. Ah. Yeah, it's hard to celebrate that one. See, that was easy. Yeah, it was easy if you don't make a bunch of stupid mistakes. Note to self. Actually run the computer if you want an actual answer. Right? Okay. This one was fun if I didn't make so many stupid mistakes. And I probably don't like this instruction thing now. So what I could do is like, could I make local extensions? Let's see, like, can I do like public struct register or single digit value? No. So I can do byte or char raw public bool is register raw larger equal a like this. Public char register like this. Public byte value raw minus 0. Something like this, right? Public implicit operator like this. Yeah, something like this. Raw const value can be larger than 9, so your minus 1 can be negative as well. I did it. Let me quickly check the input again. Like it's only for this case, right? It has the copy. like here. Oh yeah, it can be more than that. But for the first value, it can only be positive values. So it can be a byte. Okay. But I could do this. We just do it the other way around. So this all works. And now I just do a string that value. So I can do it from byte. I can probably also do it from string. So if value that length larger than 1 or value 0 larger equal to 0, like this, treat as raw, right? Value as 2-digit. So I can do this. So I can do return new this. This is also annoying. I can just do bool is register like this. Yeah. So now I will just tell it how to interpret, and now I can't do it from this one either. Nineberry says some people wrote code optimizers that detect the purpose of loops in the code and then replace them with simple operation like multiplication. That can speed up part 2 a lot, but it's fast enough without these optimizations. Okay? Ah, like that. Yeah, yeah. Actually, I will remove this. I will just make it not an implicit operator because I don't like that. I will just make it a function called parse like this, and then we do return new. And this could actually just be a record now, but it's fine. That's the constructor there. Like this. And this will be value 0. Amber says there was some puzzle in some other year where that was necessary. Yeah, I can remember. There have been some really tough ones. Um, um, okay. So now we could do. I never saved the actual input there, or the actual result that I needed to put in. It was this one. Let's save it here as well. Boom. So now we could make the instruction just be like this. So and now we could do register parse parts 1 like this. Let's see, there was CP and G and Z have the 2, and otherwise like this. Okay. Now I need to take the logic back to know what it does. Decrement will always just be A. Copy will be, let's see, what did it do? X into Y, so this one becomes B dot register equals and here I can actually do something like this. I can pass along the registry. So I can do public long get value. So if is register return registers return value. So now I can just do this. I dot B dot A dot get value registers. So this one will sort it out themselves what it needs, and now all the code becomes at least a bit cleaner. The A and B isn't optimal, but I think it's better than this. So jump not 0. So it becomes if I dot A dot get value registers not equal to 0, either b that could that also reference? Who cares? I'll just do it. I just do get value. Int offset is either b dot get value registers. I mean, this should never be a register, but who cares? And the value here can be long. So var offset like this. Woolly Master says, hey, more Advent of Code. Love it. Welcome, welcome. Happy to see more people that love Advent of Code. I'm just refactoring my day 12 solution here. I had something that I didn't really like, and I like it a lot better now. My instruction index never needs to be that big, and we know by now that this one is set here always. So let's see if the code still works actually. Arithmetic resulted in an overflow. Nice. Let's see, what is the value here? -2. Yeah, that is correct. Oh yeah, this can be a -1. I forgot about that. Let's just make it an int. It's fine. And I think this one already, no, this one will do it too long, that's fine. Yes. Is there other conflict there? I don't think so. C was not present in the dictionary. Get, oh yeah, this needs to be dot try get value like this. Out of val or 0, because it doesn't have to exist. Instruction out of range -9. Interesting. I wonder if my instructions is off. Let's see. You could have used sbyte instead to save memory and still have assigned CPU registers. Yeah, true. And the values never get that big, but since it also returns register values, I need to actually, well, yeah, for the local version, that's true. Let's see, what was I doing? There was an issue with the instruction index. Let me see. First, I need to check if these are all okay. Let's see, program, quick watch. Should probably do a toString there, just to make them more readable. Public override toString is register value value. this one, and then the instruction thing itself also can use a override to string. So this one becomes name A B. Okay, so if I run this again, at least our program, it will still error out, but that's not a problem. At least this one will be readable. And let's see if it did something weird here with the new instruction parsing. So let's see, puzzle input. See, it does -25, -28. So my number parser there is wrong, and that's probably because I use a overload that doesn't do negative numbers. So I'll do to number, and this one needs to be int.parse, because I use a shorthand that only does positive numbers. I think that's the one, the issue. Part 1 works, part 2 works. Okay, so that was the issue. I used my two numbers that skips all the sanity checks and just treats everything as a number, and when you have negative numbers, that doesn't work. So nice. So yeah, at least I like this version better. So instead of all the convoluted ways that we had, this instruction with all the options, now we just have something that has either 1 or 2 arguments, and it can be either a register or a single digit value. It's not a single digit value. I should call this register or value. So yeah, at least this it's a budge cleaner. And I could probably have actually just done like new instruction, this, and then parts.length equals 2, and then do this. Or no. Like this. So I could have just done return this, and I should probably also just do like a parse here. It's actually, yeah, this is actually the parser there. So I can do another one. Oh. So then we take this one. So this is the basic from the 3 parts. So we have the name, an optional second one, and this one should just be parse, and then we take this like that. Boom. At least that cleans up the code a bit. And now I wonder if I could make this I wonder if it gets weird if this would be an S byte. Yeah. Because then I would have, does that work? No. Never mind. It's okay like this. It's fine. It's fine. I'm happy with the code as it is here. So yeah, I think we'll conclude things here. I hope you guys had a bit of fun. I had fun, but I'm getting kind of tired. It's getting late, so let's see if we can rate somebody. software. Oh, how does that work? Let's see. Oh, that's loud. Let's see. Not game development. Let's look in the set of streamers to see if there's. Oh, that looks cool. Co-op RPG, actual role playing. I like that. If you don't mind, yeah, I'm gonna do that one thing. I think. Let's see. Do we have audio? Okay, maybe not. Am I too picky? The 11 part 2 is still open. yeah, I know, but it's getting late. I will. Ah, Smap, you answered to Smap. Missed most of the stream, but good to see you succeed for both days. Yeah, I finished part 2 at day 12. I still need to go back to 11 part 2. I'll just raid him again. We've done that before. So let's do raid. Boom. Does that work? I need to do that here. Okay, so thanks everybody. I hope you had fun. Let's go and say hi and see you next week. 1 second, okay. Bye bye.